This is the video for Mod 4 Lesson 2 on multiplying and dividing rational expressions. This section is really just kind of an extension of what we did in the previous section. So the goal is going to be really just taking the factoring and the simplifying we've been using and now multiplying, and again that's what product means, so finding the product or multiplying two rational expressions and finding the quotient, which is really just dividing, and then simplifying. So we're really just adding one additional step in there. The first example we're going to look at is we have two rational expressions that are being multiplied with each other. The nice thing is when we're working with multiplication, it's really just like you're multiplying across, and essentially it's like we're putting these all on the same part of the fraction bar. So if this is in the numerator for the first fraction and x plus 3 is in the numerator of the second fraction, when we rewrite everything in factored form, it's like we're just putting them on one giant fraction. So really the steps are very, very similar. It's more of just the problem looks a little different. And we might have a little more simplifying we need to do. So the first thing we're going to do is start like we did last time. I'm going to actually just go from left to right, and we're going to go ahead and simplify all of these out. So on the top one, I have, if I go through my checklist, I don't have a greatest common factor. I don't have a difference of two squares for this first term. I'm just going to factor it out. So I'm looking for factors of 8 that add to 6. So multiply to 8. Adds to 6. And you're going to find that it's a 4 and 2. So the first one is x plus 4, x plus 2. The bottom part, if we look at that, same deal. So I'm going to go ahead and factor this one out. So factors of 3 that add to 4. And that's going to be 3 and 1. All right, so far nothing really too different that we saw from what we saw already. The only thing that's different is now we're taking this second rational expression. I usually suggest if there's no parentheses, add parentheses around the term just so you don't accidentally separate them out. And so from here, it really then becomes the same type of problem that we already saw. So it's like this is like one giant fraction bar because we're working with multiplication. It's like you're just multiplying across. So now we're going to go ahead and do what we did before. So I'm first going to look what, if they ask for domain. I'm not allowed to make this bottom part equal 0. So I know I can't have the opposite of 3, which is negative 3. The opposite of 1, which is negative 1, the opposite of 2, which is negative 2. And then now we're going to go ahead and reduce this out. So I do see an x plus 2 that cancels, an x plus 3 that cancels, and now we're left here with x plus 4 over x plus 1, and that is our final answer. So again, same thing, we just have a second rational expression, and then if we needed to factor it, we would factor and then simplify. The second example is very similar. This one just happens to not be written as a fraction, but just like you would with values, it's really like the same as writing it over 1. And then we basically do the same exact thing. So I'm going to go ahead and just start factoring and kind of, again, using like a checklist almost, right? So on this first one, I do see I have a greatest common factor of 3x. And so if I divide each one by 3x, I'll have x plus 2. The bottom of part of that is a difference of 2 squares because it doesn't have a GCF, but I do see 49 is a perfect square. So that becomes x plus 7, x minus 7. And then the second part of the rational expression, or that second rational expression, I have a 1 on the bottom still. I might write a 1 there as like a placeholder. And then we're going to go ahead and factor it out. So factors of 14 that add to 9. So numbers that multiply to 14 but add to 9. And that would be 7 and 2. If the question was asking for the domain, again, the only parts on the bottom are the x minus 7, x plus 7. So my domain would just be taking the opposite. And then from there, we would just go ahead and simplify like usual, right? Because it's like this is one giant fraction bar. So we do have an x plus 7 there. And that's really the only thing that cancels out or reduces. So I would just rewrite this answer. So 3x, x plus 2. I actually have 2 x plus 2's here. So instead of writing them twice, I can write it to the second to kind of save some, kind of the shorthand way. And then I can write x plus 7 on the bottom. If you're asked to multiply it out, you could, but we can just leave it like that for now. This last multiplying example is a little trickier because it has a leading coefficient bigger than 1 that we have to factor. But again, same thing as before. So it's like there's a 1 underneath here, and then we're just going to factor each little piece. And then just try to be organized along the way. So this one, the top part here, factors of 6 that add to 7. We would have 6 and 1. The only difference is this one has a leading coefficient of 3, right? So when we factor this, remember we have to divide the factors by 3 to see where that 3 divides out. And then we get x plus 2, 3x plus 1. And so that's going to be, and I'm going to write my big fraction over here. So that's going to be my first part I factored. And I'm maybe going to switch colors. And then the same thing, so the bottom part, same idea. So factors of negative 30 that add to negative 13. We're going to end up with negative 15 and 2. This one we also have something other than 1 in front, so leading coefficient of 6. So when we divide this out, negative 15 over 6, x plus 2 over 6. If we reduce that, that would be 5 halves and 1/3. Or 2x minus 5, 3x plus 1. And so that would be our bottom part. And then the last part that we have to factor is the 10x squared minus 25. And so when we go ahead and do our checklist, it actually, this one's actually probably the easiest of the group. It's actually just a GCF. So I can divide by 5x. And so we would get 5x out front and then 2x minus 5. If the question is asking for the domain, you just set each one to 0. And this one, we can't just say it's 5. We have to go a little bit further. And so when we set each one to 0, we would get that our domain is it can't equal 5 halves or negative 1/3. And then now we can go ahead and simplify it out. And so when we simplify, the 2x minus 5's go away, the 3x plus 1's go away, and so we're left with just x plus 2 times 5x, or sometimes we like to write that monomial or that, that non-binomial first. And that would be our answer. For the next type of problem, we're going to be dividing rational expressions, which is very similar to how you would divide with actual fractions. So if I had something like 2/3 divided by 5/6, for example, remember that's the same as multiplying by the reciprocal. So you'd flip the fraction, essentially, the second fraction. And then same thing, if we wanted to cross cancel, we could. Or maybe you just multiply across. So it's the same thing we would do with regular fractions. We just have to make sure we're factoring first. And if needed, we find the domain if we're asked to do that. So for this problem, we're going to first just rewrite it. So this one we're dividing. We're going to rewrite it where we're changing it so that we're multiplying by the reciprocal instead. So I have x plus 5 on the bottom here. I'm now going to rewrite that second one where I flip that second fraction. The nice thing is these are kind of in factored form a little bit already. So if I wanted to find the domain, that's the opposite of what's here. So that's -5 and 6. I can then see if there's anything I need to factor. So I do need to factor that top binomial. It does have a GCF. And then we're going to go ahead and simplify if we can. So in this case, we do have x plus 5s that can cancel. The x minus 6 can reduce out. And we're left with just the 2x. And that's our final answer. The next example is very, very similar to what we already saw. We're just rewriting it. So we have here x squared minus 16, x squared minus 10x plus 25. And then we're flipping that second fraction. And now we're just going to go ahead and simplify all the different pieces. So the upper left is a difference of 2 squares. The underneath, this is a trinomial, so factors of 25 that add to -10. So it would be -5 and -5. For this top upper right, or that numerator for the second one, factors of -10 that add to -3. So that would be -5 and +2. And then the bottom, if we're going to go through our checklist, it's just a GCF, so I can pull out a 3 from both of them. If I'm asked to find the domain, again, you're just looking at the bottom. After you flipped it, you're looking at the bottom. And so we have that we can't have 5, we can't have 4, and then this 3 is just there. And then now we would, like last time, just kind of make one large fraction. And then simplify it out. So we do have an x minus 4 that can go away. We have an x minus 5 that can go away. And that's basically it. So on the top, we have x plus 4, x plus 2. On the bottom, I might pull this 3 out front just so we don't lose it. And then you can leave your answer just like that. For this last example, again, same thing, we're going to go ahead and simplify. So we might first, if we want to rewrite it, you don't have to if you know you're going to flip the second fraction. Because again, this is a division problem. So we basically are multiplying by the reciprocal. And I'm going to rewrite it where now I flip that second fraction because we're dividing. And now we're going to go ahead and factor each piece, right? So again, we're always thinking of our checklist. We look for GCF first, then difference of two squares, and then we factor if it's a trinomial. And all of these are going to, if they are a trinomial, have only a leading coefficient of 1. So if I start with the numerator for the first one, I do have a GCF. They all have an x, and the smallest degree is a 2, so I can pull out an x squared. And I can actually go a little bit further. Inside the parentheses, a trinomial. So factors of negative 30 that add to positive 1 will be x plus 6, x minus 5. We're going to then do the same with the bottom part. So factors of negative 18 that add to negative 3. We're going to get x minus 6, x plus 3. I might write it down here. If I then go to the next part, so this is a difference of two squares, I'm going to have here x plus 6, x minus 6, and then for the, and then I might rewrite it down here. And then for the last piece, that denominator of the second expression, I have a GCF of x. They all have an x in common. And then factors of 30 that add to 1, that'd be 6 and negative 5. And now we're just going to, again, like last time, we're gonna, if they ask for the domain, this one's nice and easy. It's just the opposite of what's in there. So we can't have 6. We can't have negative 3. This is going to be, we can't have a 0. We can't have negative 6. And we can't have 5. And then we can go ahead and simplify factors that are in the numerator and the denominator, so what's on the top and bottom. So x plus 6 can go away, x minus 5 can go away, the x minus 6 can go away. We also have here, there's an x to the 1 and an x to the second, so when I cancel, I'm just left with a 1. So on the top, all I'm left with x and then x plus 6. And on the bottom, we're just left with an x plus 3. And this is our final answer. If you have questions, make sure you are trying the U-Try problems and then asking for help during class, signing up for T-Bolt time, or getting help in the center.